When the polynomial px equals to x raised to the power 5 plus x raised to the power 4 plus 5x square minus 3 is divided by x plus 2. So you can consider this is by qx. The remainder is. To find the remainder, if some expression divide given polynomial, it means I can write x minus of minus 2. This is polynomial or divisor. If this is a divisor for this given polynomial, then p minus 2 will be the remainder. Will be the remainder. If this is perfect divisor or perfect division is possible, so we will apply factor theorem, and this will give you, if this is the factor, then this one give you remainder 0, will give you remainder 0 only when this is factor. But this is not a factor, it is a divisor. That's why p minus 2 will be the remainder. Now put minus 2 in place of x in the given polynomial px. So minus 2 raised to the power 5 plus minus 2 raised to the power 4 plus 5 minus 2 square minus 3. We have minus 32 plus 16 plus 20 minus 3. This one equals to 36 minus 35 equals to 1. Option B is correct. If the identity element E belongs S in a semigroup S star, then it is said to be monoid. How? If S is a set and a star is a binary operation, we say binary operation, it means a closure property already hold. Closure property already hold. If this set or set with binary operation satisfy the property of associative, then we will call groupoid. If identity also belongs to this set with binary operation, then it is called monoid. And inverse, if A inverse belongs to S star, then we will call group. So S star is a semigroup. Semigroup, it means two property already said in direct way. One is closure and the second one is associative. And saying that identity will also hold in this set, then we will call this set S star as a monoid. Option C is correct. The number of generators of J24, usually we know that Zn is cyclic group, and if we want to find number of generator of a cyclic group, you can apply Euler-5 function over n. This is J24. If we do prime factorization of 24, what we have? We have 8 into 3, and this one can be written as 2 raised to the power 3 into 3. Euler-5 function apply over 24. We have 5 2 raised to the power 3 into 3. It means 2 raised to the power 3 into 3, 1 minus 1 upon 2 into 1 minus 1 upon 3. This one equals to 2 cube into 3, 1 upon 2 into 2 upon 3. 2 cancel out by 2, 3 cancel out by 3, 2 cube. This one equals to 2 cube, and 2 cube is 8. Option C is correct. A silo 3 subgroup of a group order 12 has order. In compact way, I can write order of 3 SSG of a group of order 12. So we need to find this order. Order of PSSG is equals to max value of prime and its power, suppose n. The value of this p raised to the power n will be order. In a group of order 12 has 2 square into 3, and we need to find order of 3 SSG, 3 containing here, and order of G. So max value is 3 raised to the power 1 equals to 3. So option B is correct. Given a matrix A of this size 3 cross 3, the characteristic polynomial of A is, you can find characteristic polynomial as px denoted by px, and this one can be find out with the help of determinant of A minus lambda I. But there is not this is not a perfect way to answer this problem in a short time or duration exam. Trace of this matrix A is equals to 5, and this is a matrix of this size 3 cross 3. That's why it's a polynomial having the structure x cube minus trace of A plus adjoint of A11, means first entry in first row and first column A22 plus A33. X minus determinant of matrix A. This is characteristic polynomial given by this one. If we have polynomial suggestions, as you can observe in options, so x cube and trace is 5, that's why 5x square minus 5x square is the term of in option C, that's why option C will be correct. Find the eigenvalue of this given matrix. To find the eigenvalue, first we find trace of this matrix called A is 5 and determinant of this matrix is 0. Sum of eigenvalue is trace and the product of eigenvalue is known as determinant. So which one option giving you product of eigenvalue 0? Only option C giving you product 0 and sum is 5. That's why this option C will be the right key for this problem. Let V be a finite dimensional vector space and I be the identity transformation on V. It means I is linear transformation from V to V. Then null space of identity transformation Ix null space. So identity transformation we can define Ix equals to x and null space of Ix equals to only 0 element. Because of identity transformation send 0 to 0 and other elements as x. So there is only element which is going to 0, that's why null space contain only 0. Option A is correct. Let S be a non-empty set of real numbers. Option A, infimum of S equals to supremum of S, and you can see other options also. For this we consider set S as a sequence xn, and this sequence is nothing but 1 upon n. Then we know that supremum of this sequence S is 1 and infimum of S is 0. So you can observe supremum is not same as infimum of S. Option A has been discarded. For options B, if we consider minus S, then it will be minus 1 upon 2 minus 1 upon 3 and so on. In this case, infimum of S is 0, but supremum of minus S is again 0, and both are same. So option B might be same if I take negative also. In option C, we are not confirming option B is perfect. In other case, it may be wrong, but it seems it may be true. For option C, infimum of S is 0 and supremum of minus S is also 0. So option C might be true. For option D, infimum of S is 0 and supremum of S is 1. If I take negative, then minus 1. Both are not same. So option D has been discarded. Now we have to choose either option B or option C is correct or not, or which one option is correct. For this, we consider set S as 1, 2, 3, 4. There are 4 elements, and minus S as minus 1, minus 2, minus 3, minus 4. Now find the infimum of S, that is 1, and supremum of minus S is minus 1. Now you can observe both are not same. Option C has been discarded. Now option B has been confirmed and it will be right key. A real valued function f has discontinuity of the second kind at x equals to a. The condition is if neither f a positive nor f a negative exist. It means that right hand limit RHL at x equals to a and LHL left hand limit at x equals to a doesn't exist. Option C is correct. The order and degree of the differential equation as d2y over dx2 is a differential coefficient, and we are integrating this differential coefficient again with respect to x. So new differential coefficient will be d3y over dx3. It means order of differential equation will be 3 and max power of this differential coefficient will be 1. So option C will be correct. In this problem, you have to careful. Please do not consider d2y over dx2. So 2 is not a order of this differential equation because of we are doing differentiation again with respect to x. So this will be required differential coefficient to tell order. The value of the Wronskian W, x, x square, x cube, there are 3 functions and the Wronskian is determinant of this one, means x, x square, x cube and its respective derivative 1, 2x, 3x square, 0, 2, 6x. Now expand this determinant along first column. So we will have x outside 12x square minus 6x square minus 1 6x cube minus 2x cube, and from 0 into whatever the number. This term will go to 0. Finally, we have x into 6x square minus 4x square 6 4x cube. This is 4x cube. 6x cube minus 4x cube. Finally, we have 2x cube. 2x cube is given in option C. That's why it is correct. The orthogonal trajectory of the family of curve x square minus y square equals to k, we can easily find out x square minus y square equals to k. The procedure to find orthogonal trajectory, first differentiate this equation or family of curve equation and replace dx dy over dx with dx over dy and take negative of its, because of if two curves are orthogonal, their slope having the value or having the relation -1 means m1 into m2 equals to -1 if m1 and m2 are representing the slope of different curves, and replace a arbitrary constant using the previous equations. So first step is differentiate this equation, that will be 2x minus 2y equals to 0, dy over dx equals to 0. Now minus 2y dy over dx equals to minus 2x, minus 2 cancel out by minus 2. Now replace this one, dy over dx equals to x over y. What we have? Minus dx over dy equals to x over y. This implies that minus 1 upon x dx equals to 1 upon y dy plus log c. Finally, we have minus log x equals to log y plus log c. Transposing the terms, log x plus log y equals to log another constant c1. It means xy equals to c. This type of orthogonal trajectory. xy equals to c, option B is correct.